Okay, I think we're good. So let's get started. So today we're going to make a Twitch overlay chess game of some kind. I mean, I've already told a lie. I think today we'll make a chess game that you can play like single player in the browser, and then maybe in the next stream we'll work on actually integrating it into Twitch as an overlay and integrating it with the chat. Like ultimately, I would love it if people could put a command into the Twitch chat to start a game. Somebody else could then accept that challenge, and then they could just input their moves back and forth and have it play out like in a little bit up here or something on the screen, you know, and then the bot could announce like in the chat or as part of the overlay, like when somebody wins or when it's check or all of that kind of stuff. Yeah, let's have a little think first about what we need to do to kind of achieve this kind of thing. So I'm going to start off with a little kind of to-do list. First thing I think we need to do is to be able to draw a board. Kind of a no-brainer. Next one is to draw the pieces on the board. Probably then we need some way to like track the position of pieces. Then I think maybe some way to move the pieces. And again, this will need to be hooked up to Twitch chat ultimately, but I think for the time being, I'll just have a little text box where I can put in moves. One nice thing about this is it's all going to be done by text, so I won't actually need to do like mouse controls for dragging stuff around, so that actually makes it quite a bit easier. The other thing is that it's going to be player versus player, so there won't be an AI, which, you know, a lot of the complexity of making a chess game is actually implementing the AI, so we sidestep all of that crap by just making it two-player, so it's actually way easier this way, I think. But one thing we do still need to do is check for legal moves, right? We don't need an AI, but we still need to know what moves somebody can make, and if they put a move in, whether it's actually a legal move for that piece. So the way I'm thinking about this is the first step would just be to allow them to put any like coordinate on the board and just have the piece just jump there, like teleport to there. And the next step is to restrict that and sort of detect when they put in an illegal move. Then there's some more complex stuff. Maybe we won't tackle it in exactly this order, but there are like special moves, right? So chess has castling and en passant, which are kind of like special case moves, which also require tracking a bit of information. Like you can't do certain things if a piece has already moved previously in the game, so there's some extra stuff we need to track there. I guess the next final one there is detecting check, right? So knowing when the king's in check, which kind of ties back to legal moves, because if the king's in, you know, the king can't make a move that puts him in check. And tied along with that is detecting checkmate, which means, you know, if you're in check and there are no legal moves, then that's checkmate. So there's a bit of logic there which needs to be done. Okay, this is starting to feel ambitious for one stream, a couple of hour stream, but, you know, let's see how far we can get down this list at least. And then we have other stuff, which is actually maybe a bit more complicated. So detecting a stalemate. Actually, probably stalemate's not too hard, but there are other like what's the word? Other ways to draw a game, right? Like if you repeat the same moves too many times, there are conditions like that where the game ends in a draw. Like if you just keep cycling through the same moves. I'm not actually 100% sure what the exact rules are around that, so that's something we'll have to look up as well. Threefold repetition, yeah, that's the one. And there's also like a 50. Is it a 50 move? Yeah, I would actually have to. I'm vaguely aware of these, but I'd have to look up the actual specific definition. Maybe we can put some more details so we have. Threefold I can't spell. Repetition, and is it like the 50 move rule? There's something like that. Maybe I'll break this down as well into castling and Is that right? How did... Okay, Google time. Pass on. Okay. All these French terms. There may be other ones, like, yeah, I'm no expert chess player. Like, I recently became interested in chess again. Like, I knew the basic moves and how the pieces move around, and I played a little bit as a kid. But with the massive resurgence of chess recently, like on Twitch and YouTube, I started seeing stuff come up. I also watched the Queen's Gambit and was super into that. Like, I really loved that, and it gave me that little spur to try out chess again. And yeah, I've kind of been enjoying that quite a lot since. As I said, I'm not very good. I'm still like in a beginner stage, like a sub 1000 kind of stage. But you know, I know a couple of openings and the basic moves and rules and stuff like that. Okay, let's actually get into some of this. Maybe I can actually put this up like here. Is this going to work? Don't know if this is useful for you guys. Oh, okay, I'll just kind of leave it there. So the thing I'm going to use to create this is something called P5.js, which is a JavaScript library for graphics and interactive applications. It's actually a really cool project. It's designed for kind of newcomers to programming, also people who are like artists and want to make interactive visual stuff, and it makes it very easy and direct to like just start drawing stuff and doing graphics and interaction and stuff like that. When it comes time to integrate this into Twitch, it might be a bit of a pain, but for this stream at least, I'm just going to focus on getting this working. It looks like I created this project, which they call a sketch in processing, and it's come up with this default thing, which just draws a load of dots. The way P5.js works, there are two main functions. There's one called setup, which starts like when the program starts, and then there's one called draw, which is just called like over and over. So I'm actually going to replace these with something else. The first thing I probably need is to define like something like a grid size, right, in pixels. So actually let me pull up. Okay, now let's open these in an image editor so we can figure out how large these images are. I'm guessing they're 32 by 32. Okay, no, they're 42 by 42. And to give them a little bit of room to breathe on the grid, maybe we go for like 50 by 50. We'll be able to tweak this, so should be no problem. So how big should our canvas be? Well, it's kind of obvious that we need 50 by 8. I know enough to know that chess is a 8 by 8 grid. Let's reset this. You can kind of see this in the middle here. Let me actually do something like this so it's you know, easier for you guys to see on stream. And I'm just going to give it a white background because that's also easier to see. Okay, here's our little area here. The first thing for me to do is to make a function which is going to draw the board. So how do we do this? I guess we need to get my little sketch open. So to draw a board is conceptually fairly simple. We've got this area to work in. So probably what I'll do is maybe just fill this with like the light color. So like a white or like a kind of ivory color or something. And then I'm just going to draw on top like the black squares. I feel like that kind of makes sense. Probably going to be the easiest way to do it. Let's just bring up a little reference image here to help us. I guess we'll do it from White's point of view. Cool. I'm actually gonna... Oh, this will be nice. Okay. It's going to be a lot of referring to chess coordinates, so I may as well bring this up. So let's open this thing, right? So I was originally going to do like X and Y, but like maybe I should use like rank and file variables. That feels more proper, right? So so let's go over all the ranks. So these nested loops will go over every like grid position for us. Just for now, let's draw a little circle. Oh, you know what? It might also be handy to... So what I want to put here is the coordinates of that tile. You know what? Okay, let's just do... So file is kind of our X, right? The next parameters to this. So this is kind of going to draw an ellipse, or in this case a circle, with a certain size, like 5 by 5 at a certain position. And I believe this should... Let's actually clear the background out. Yeah. Draw this. Okay, so we are kind of drawing the grid squares here. We've actually got the coordinates like in the top left. It's probably going to be more convenient to think about the coordinates like in the middle of these grid squares, because you know that's where we're going to draw the pieces. Yeah, like by default, like coordinates going to start in the top left, but I think the middle is just going to make more sense. So I'm going to make myself a little helper function. To get the screen position of a particular like coordinate on the board, if you like. And I guess it should be file and rank, right? File is X. This is already confusing me. I'm so used to doing X and Y for this. So let's do... So what are we doing here? So the X coordinate is going to be... So file times grid size is kind of what we did before. That gives us like this X coordinate here. Then we then want to step across like half a grid square, which will get us into the middle. That's kind of what this is doing here. So file 0 is going to be at 0 times 50, which is 0 plus 25. So 25 pixels in from the edge, which is in fact this position right there. So that gives us X. Actually do this. Something similar with Y. So this is a handy function to convert from a rank and file position to a X and Y position. So we can use that here. And then we can plug those coordinates in just like this. Now, I could have just done this calculation inside here, but I figure this is going to be something we probably want to do very commonly. We'll also need to get this position when drawing the pieces themselves. If we were doing any like UI mouse stuff, which we're not, but if we were, then we would probably need this as well. So, you know, in games it's very common that you'll define a function that goes from like the coordinates of the game world, if that makes sense, to the actual on-screen coordinates and account for any like scaling and camera movement and stuff that's going on. In this case it's pretty simple, but we still need something like that. Let's rerun this, and now we have a little dots in the center of each thing. So what we can now do is basically figure out which squares are light and which squares are dark, right? That's an interesting little thing we need to do, because the dark squares we're going to draw squares on, and the light squares we're just going to leave as the background color. So how do we do that? Oh, also I've kind of got the coordinates backwards, right? Because rank 1 or rank A actually, or sorry, yeah, rank 1. Is rank 1? Yeah, starts at the bottom, whereas I've got it actually at the top, so probably to be consistent with the actual chess coordinate system, I probably want to kind of invert this, if you like. It's going to look the same. Basically, we're drawing them like this one, then this one, then this one, then this one, but really this is like the A1 square, so probably this should be reflected in those coordinates. So it will look the same. We've just drawn them now, like starting here like that. So how do we determine what's a dark square and what is a light square? There are loads of ways we could do this. We basically want a formula, right, which will do this for us. I'm just going to drop this in here. So there are a couple of ways, right? We could say, oh, if we're on like an even numbered row, then we know that those start with dark squares. So then we could then look at the column or the file, and if that's even numbered, then we know it's a dark square. Alternatively, we could just count, like start with this tile, then this one, 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 and use the fact that they alternate. Like that could be a thing. What I'm looking at this now and thinking is that if you think of this as like, let me put that down there. If you think of this as like 0, 1, 2, and so on going along this way, because that's kind of how computers count. Similarly here, 0, 1, 2. We could say that, so this is dark, right? And this is an odd number, sorry, an even number, and this is also an even number. So I think it's the case that if the rank and file sort of numbers, if they're both odd or both even, then it's a dark square, but if one's odd and one's even, then it's a light square, right? That's kind of a relatively straightforward way to get to this. So this is file 1 and rank 0, so this is odd, this is even, those don't match, so it's light. That's kind of a kind of mathematical way of talking about what's a dark square. Another way would just be to list out all the 64 squares and whether they're light or dark in a big like table. And honestly, that would be pretty valid to do, but I guess we'll do it a slightly fancy way. So I could make this really shorthand, but okay, let's actually do it longhand and then maybe condense it. So file is even is equal to so this is the modulus operator. If you're not familiar with this, it basically, this is kind of saying divide it by 2 and give me the remainder. So if file is 0, then this would be 0. If file is 1, it doesn't go into 2 any times, but the remainder is 1, and so on. So it will kind of effectively tell us if it is odd or even. So we could do the same thing for rank. But actually a way to write this more succinctly is, I believe the file mod2 should be equal to the rank mod2. If that's the case, then it's a dark square, I think. So let's do something like this. So we say if is a dark square, then we're going to do this stuff. Is this correct? We shall see. Oh, I'm okay, missing a bracket. That's what it's complaining about. It was giving me a weird obscure error there, which often happens because a bracket is missing. Okay, this looks to match to me, so yeah, right, because you've got the dark square in the bottom left and the top right. It looks to me like we have replicated that pattern. So now rather than drawing these little dots, let's instead draw a rectangle. So this is kind of a quirk of processing that I want to draw rectangles. I know the center position and I want to draw like squares or rectangles. Because the square is a kind of rectangle kind of centered on those, so I can put this to have things drawn in like a centered fashion. So it's going to be like this, and then I do the width and height, and the width is just going to be grid size by grid size. So this should now hopefully give me some squares where the dark squares are. Awesome. This looks weird because I've just drawn outlines, so in fact what I also probably want to do is to say no stroke, which means don't draw an outline, but I want to give it a fill. I mean, I could just say black just to test this out. We can figure out a nice color scheme afterwards. Cool. I think we have a chessboard. You know what, let's actually set so I think we can use so we should probably set some things up here for the colors. So the light color can be, let's see, let's get a color picker. What's a good light color, right? Because they're normally not actually black and white. I kind of like the green color scheme personally, but we shall see. You know what? Why am I doing this when I've got GIMP right here? Okay, so I guess the light color is often like that. So we can just copy this. Like an off-white browny kind of color. And then the dark color. One thing I'd like to do when we integrate this as a Twitch overlay is to actually maybe allow this to be configured so if people want to embed it in their stream, they can pick their own color scheme. Personally, I'm a fan of plum purple, so maybe I will. This may look horribly ugly, in which case I'm not averse to changing it. But that's our dark color. So now I don't want to fill it with this, I want to fill it with the light color. And then, oh sorry, when I draw the background, I want to fill it. In fact, let's put this here because it's kind of part of drawing the board, isn't it? I'm going to fill with dark color. Okay. Yeah, this looks okay to me. So let's get our little to-do list up. So drawing the board. I think we can safely say that's done. Next is to draw the pieces. So let's, well, we're going to need to actually upload those kind of into the sketch here. How do I do that? I think it's stop. Change view. Okay, there we go. Drop files here or select. Okay, let me grab those things so they are here. I should just be able to kind of drag them in. I don't like this one thing. I kind of am a bit anal about this, so let's just drop them here. I'll go through and upload these for us. So what I probably want to do is, okay, yeah, so in processing there's this thing which is called once of the program. There's this one called draw, which is called every frame, if you like. There's also something called preload, which is basically used for like preloading like images and audio and any other assets. And it's kind of a quirk of how the web works, that it needs to go off and download. Your browser will essentially go off and download all these files separately. So there's a whole rigmarole about waiting for all those separate downloads to finish. But preload will, I believe, handle that for us. So let's create a little list of piece names. So we have pawn. I should know this. Pawn, king, queen, bishop, rook, knight. Nope. Knight. This would be my chance to rename it too horsey, but I will hold back on the desire to do that. So now I've got these piece names. What I kind of want to do is go through all of these and load them kind of into this piece images DB. So this is a way to do that. Yeah, so it's easy enough to load the kind of light ones. I can just do name plus .png. I believe this should work for us. You won't see any difference here, but it should work. Let's try a little test where we just draw image. So let's look up the king, and let's put it, I don't know, a sort of random position just to make sure it gets drawn properly. There it is, okay. So clearly these images are getting loaded. I also want to load the dark equivalents. I was going to do something more fancy, but actually this should work. Name plus dark. Right. So this little thing, this loop is basically having to avoid me manually listing out all of these pieces, but there's not that many. I mean, I could have just done that. Maybe I'm being too fancy. But let's check that king dark gets loaded. Let's replay this. And there is our dark king right there. Okay. So another thing is that this doesn't really belong in here, is it? That's not drawing the board. It was kind of only a test, but this would actually do is something like so let's say we wanted to do A1, right? It's like 0, 0, I guess. So then we draw an image, draw. Let's draw the queen at Y. We should also do, actually let's just run this and see how it looks. Okay, we can see our queen down there, but it's kind of, you can see what's actually happened is the top left of this queen image has been drawn like right on the center point of this tile. What we actually need is something like image mode center. Oh yeah, and then she gets drawn nicely kind of centered on the tile there. Okay, that's all good. So technically we can draw the pieces. In order to draw all of them, we're kind of going to need a way to track the position of all of these. There are different ways to do that. You know what, first of all, something that's going to be handy, I think, is to be able to Okay, so I kind of want to do something which will be able to understand at least a little bit of chess notation here. So, or rather, I just want something at least where I can pass in like A1 as a bit of text, and it will give me back, hey, that's actually 0, 0 in our kind of rank and file kind of coordinate system here. So something to convert from this letter number thing to the number-based coordinates, which computers obviously kind of need to use internally. So I'm expecting this to be, let's call it position string, because that's kind of what we want. So we're assuming its length is 2, right? So we could say, yeah, I'm going to get rank and file confused forever. So, okay, A is the, this is a rank, right? This is the back rank, so the rank is the number. So the file is the letter, the rank is the number, okay. What we're doing here is we're pulling out the first character. So, you know, this could be like A1, right? File, letter, and let rank number. Let's pull out the second character. Again, computers like to start counting from 0, but chess players like to start counting from 1, like normal human beings. So we're going to need to account for that as well. So, the actual file is going to be... Okay, this is going to get a little bit tricky. What I want to do is find out how many... So we know that A is 0, B is 1, and so on. Again, we could just sort of predefine that. But a slightly fancier way to do it is... is leveraging the fact that... Oh, okay, here we go. That inside a computer, every different character has a certain number associated with it. Again, computers just all understand numbers under the hood. So there's something called ASCII, which is kind of the standard, if you like, for what letters have what numbers. So like the letter A here, or a capital A, actually is like number 65 under the hood. That's kind of how computers kind of store those numbers. So we can use that to our advantage, right? So actually, yeah. So assuming this is like a lowercase, right? So we can say it's going to be equal to... No, we actually no longer need to do this at all. So we can use this function. Where is it? This function character code @ to get that number associated with any given letter here. So okay, this may look a little weird. What we're doing is we're basically saying get the numeric version of this, right? So A was what was A? Case A was over here is like 97. The specific number doesn't really matter, right? But so let's say it's A1, then this would be 97, and then the character code of A is also 97, so this would give us 0, which is actually what we want. If this was B, then the first character would be 98, so then we would subtract 97 and it would give us 1. So it's basically, this is saying how many characters after A in the alphabet is the thing that's been passed in here. And that's kind of how that works. So we can do something actually very similar with rank. So we can take the first thing, and we can see how many characters after the number 1 in the like character table it is. So this is actually very common for finding out if a letter is like between A and Z, for example, or if it's some other character. It kind of depends on knowing how numbers work like inside a computer, but it's actually very, I would say it's a very common and useful thing to know. So I hope this works. So then let's return our ranking file like that. So let's test this little thing out. So let's say B2. Let's pass in a B2. Pass this in here. And then let's run this thing. This has been kind of a tangent and maybe not super necessary. Yes, there we go. So it is able to understand these. So if I do A8, you should hopefully see it appearing in A8. Awesome. So H8. Okay. I don't know why I did this now. I probably didn't need to. But the point is we can now say, hey, draw the queen at this position, and it will do it for us. And in fact, let's make a little helper function, which will... Do we do this? I'm not sure if we need to actually. Okay. So this is kind of like hard coding the position of the queen and manually drawing it. What we actually want to do is track the position of every piece and then draw them. So right now there is an important decision point, I would say, about how we store and keep track of the positions of pieces. And I think either way would probably be perfectly fine, but it's kind of a design decision for how we do this. Just undoing some of this stuff I've sketched already. Okay, I would say the two ways we could handle this is one, we could have a big actual grid kind of in the computer's memory, and then we could store in certain locations some data, right? So this is maybe like piece is a pawn, color is dark, this kind of stuff, right? So we could store pieces like actually inside like a grid structure like this. And then each one would have its own little object with all of the properties of the object, like what type it is, what color it is, and so on. Even things later, like has it moved yet, which we may need to track for various reasons. That's one way to do it. The other way to do it is we just store like a list of pieces. So this could be, you know, like type, pawn, color, light, and position is like D3, right? So the difference here is that the pieces themselves store their position, and we just have a big list of all the pieces in the game. The alternative being we have a grid representing the board, and each tile may have nothing in it, or it may have a piece. And one of the other of these may be more natural to you as the programmer, or it may just be more convenient for the things we're going to need to do, right? So something we're going to need to do when determining legal moves is say, hey, I want to move to this tile. Is there a piece there already? And in that situation, this is quite handy, right? Because we can just look in that tile and see, hey, has a piece been stored in there or not? Otherwise, what we have to do is go through the list of every pieces, looking for one with the correct position, and then do things in that way. On the other hand, like this structure where there's just a big list of all the pieces is very handy if we want to draw them, because we just go through this list piece by piece and then draw it at its relevant position. But if we store them in this way, then we'd have to go through every grid tile one by one, and say, is there a piece here? If not, we do nothing. If there is, then we draw it. Third option would be kind of doing both of these at the same time. But I would generally avoid having the same information stored in two different places like that, because you need to make sure they don't get out of sync. Right? Like if the board had information for like 10 pieces, but your list only had 9 in it because you didn't do the bookkeeping to keep them in sync properly, then that's an issue. So I would rather just have a single, I guess what we call a single source of truth, which is just one place which is responsible for knowing what pieces there are. Personally, I'm leaning towards storing them in the grid, because figuring out legal moves and checks and stuff like that is probably actually the more difficult part of this. So, to that end, I think I will create some stuff here. And I'm literally going to store a kind of like an array of arrays, if that makes sense. And but I think I'll probably populate this with a loop somewhere. So it's actually kind of up to us whether this is like by rank and file or by file and by rank. But in any case, we're going to need to do some kind of loop like this. So, okay, another consideration is when we need to look stuff up in this. So if this is an array of arrays, we can look stuff up in it like, you know, like board 3, 2. In my mind, this should be going along the X or file first and then the rank, which means that we actually want to store the first kind of sub-array within this array should be this whole thing, kind of starting here, 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 because that will allow us to do lookups in what seems to me to be the natural way, which is like X and then Y. So probably means this wants to be the other way around. So I'm going to say let what's that? Okay, and then for every rank, I'm just going to God, my JavaScript is so rusty. I just allocate. Okay, yes, I can. Push or append, I always forget this. And I'm really actually not a JavaScript programmer at all. Push. But you know, these aren't the important things to remember in programming, I don't think. Then we can say board.push file array. Okay, so this is just kind of creating the empty 8x8 grid. Oh, actually, this is wrong. Okay, it's just like this. And I can then simplify that just like this. That should do what we need. So then let's put some stuff into here. So I can say board you know, actually having a reset board function may help here, because I feel like that's something we may need to do sometimes. If you want this to support multiple games, then probably we should put this into a function so we don't have to repeat this same code over and over again. Create an empty grid. Okay. Then we need to put the pieces into it. So this is going to be a bit long-winded, but one thing we need to do here is think about the actual structure of a piece, right? So so let's start by putting a rook here. So what's going to go here? We're going to put an object here, and it's going to be, let's call it type rook, color dark. Maybe that's all we need. Let's also do, it's not dark, it's light. Let's also put something right at the top. Okay, that should put 2 rooks on the board. Let's run this and make sure nothing too crazily goes wrong. Okay, now we can change our code. Instead of drawing this queen here, let's actually have a draw pieces function. And all that needs to do is basically loop over the board again like this. And say right, so going over every coordinate in the grid, and we're looking at what piece is there, and I'm going to say if there's nothing there, we're just going to skip this. Otherwise, we're going to draw something, and the way we draw that is first finding the screen position here. So take the file and the rank, and then do that. So what image do we want to draw? It's going to be type of the piece. Okay, let's actually do it this way. So if okay, we can do it slightly more long width. So if it's dark, then the image name is going to be piece.type plus dark. Otherwise, it's just going to be the piece.type. There are many ways to simplify and shorten that little snippet of code, which I was kind of inclined to do, but I feel like this is the most, the most clear and straightforward way of doing this, at least. Okay, and then we're just going to actually draw the image. So just like this. So the name of the image is here. Draw it at the screen pos x and screen pos y. So I actually feel like this kind of maybe belongs closer down here. Doesn't super matter. This should do what we need. So then we can get rid of this junk. Okay. Is our code valid? So right now we've only put, when we reset the board, we've only put the 2, I guess, like A rank rooks there, so that's what we should see. A file, sorry. Okay. So we've done something slightly wrong there. It should actually be 0, 7. Cool. So honestly, all I'm going to do is just quickly go through and just fill out the board. I could figure out a nicer algorithm to do this probably, but to be honest, you know, there are only 32 pieces, so I'm just going to list out 32 things. I mean, it's not super clean, but it's a one-off and it's super direct and clear at least. And I may as well go like along the back. Put the bishops in. Another thing I could do is kind of load this from a file or something, but probably not all that necessary. So we've got the bishops, then we can put in hang on, that's not where sorry. Yeah, that's not where the bishop. Man, I'm forgetting where pieces go. This should be knight. This should be bishop. Okay. I'm just going to do the whole block for white actually, and then kind of copy paste that. So. Yeah, the queens stay on their correct tile, don't they? So that would be light squared. Okay. Let's just go through, change one of these. Dark. Again, copy and paste is normally not the best sign when you're coding, but I know the scope of this project is going to be small, and this is kind of a one-off thing, so I'm more or less okay with just hacking this together. Okay. Have I correctly populated the chessboard? No, because the queen should be... Wait. No, that's right. Okay, cool. I think we're there. Next thing is to add the pawns. But I think I will do that in a loop just because it's just going to be a pain otherwise. So let's actually do that at the end. So I'm going to put dark and light in the same loop. I'm going to say, copy this kind of line. Say that board file 1 has a light pawn. Board file 6 has a dark pawn. Is that correct? Okay. Let's check this out. Okay. Again, as I pull up a chessboard to double check that I haven't done anything very silly here. Yes, okay, cool. I think we have the correct layout. That took slightly longer than it should have done. So yeah, we create an empty grid, then we just put pieces. We just put the pieces in the default positions there. Let's look at our to-do list and see where this has gotten us. So we can kind of track the position of pieces. Awesome. Next thing is to be able to move pieces. So let us figure out how to do that. So I think as a little test, I'm going to maybe add a little text input down here, which we can type into. And I believe I can do that with P5 with like a create input. Okay. Then I can have it kind of do stuff. So create input like that. Yep, yep, yep. And then there's this input thing. Element. And then we can have stuff happen when certain events happen. So is it input or is it something else? Yeah. So let's say if we do that, we should just see a little box appear somewhere. Oh, it's here. Is that right? That's kind of weird. I mean, I guess it works. I wonder if we can tweak the positioning of this. Okay, so I can say, is this pixels or characters? I want to make it smaller. Oh, that's so weird. Size. Okay, so I can just say 50 by 50, maybe. It's more. Okay. Okay, and then I can also do stuff when it's pressed, right? So I can say test input. I can put in a function here. Let's try and find an example of this. We actually look up. Will that do something when return is pressed? I could have a button, but I don't really like that. Good old Dan Schiffman's tutorial. So what I'm trying to figure out is how I can detect when somebody's pressed return inside this. And then I want to kind of try and process it as like a move command, if you like. Example. See, I'm probably messing around too much trying to make this perfect when... If... How do I get the value? Try something like that. Oh. Okay, so we can detect when there's 4 characters, which is enough to specify a move. I'm going to say let move equals value out. I'm going to say let from tile name. So the idea is that I'm going to say, like, I don't know, like A2 A3, all right, to kind of specify that move. I mean, it's not the most shorthand notation, but it's like kind of long-winded chess notation, if you like. Is so I'm going to put out the first 2 letters. So I even forget how to do substring in JavaScript. Wow, what's going on there? Just kind of guess. Title name is going to be from to. Is that length or is it end? I kind of need the answer here. Oh. Okay, we managed to pull those out. Let from tile. Oh, tile. Now we're going to use our handy helper function. It's going to be, where are we? Pass position. And just to reduce the number of lines of code, I'm just going to nest this in here. I don't think we really need separate variables. So this has no validation, by the way. If I type the wrong thing in, then something weird's going to happen. So when we make this real, that's something we need to deal with. But for now, I'm really just trying to figure out the logic. So let's create a function here, which is like make a move, right? So from to so let's look up the piece, right? So the piece, I'm going to say if there's no piece, then I'm going to alert like this and bail out probably. Otherwise, I'm going to move it to its new position. Oh. That's the piece, and then I'm going to clear out the old tile behind it. Otherwise, I'd end up copying. So this is like if you ever played a game with like an item duplication bug, this is the kind of thing that causes that. Like if I'd have just done this, in fact, let's try it. This could be fun. Let us call that move function. Okay, so this is A2, and let's try and move it to A3. A2, A3. Oh, error. Move piece is not defined. Oh, it's not called move piece, it's called make move. Let's try that again. So A2 to A3, please. Yeah, see, it's kind of just copied it. I can do totally illegal moves. I can say A1 to B7. Oh, sorry, I can say A1 to B7, and it lets me do that as well. Oh, 1, 2, 3, 4, 5, 6. Yeah. A1 to B8, stuff like that. So some real basic stuff there works, but not entirely. Let's clear that out when we're done with it for one thing. And then let's make sure that when we actually make a move, that we clean up behind ourselves. So now we should have the basic ability to go from A2 to A3. Clear could not be called as a function. Do like a set value. Okay, that's how we set the value. So I kind of guessed that there was something called clear there. Looks like we just do this, clear it out, make it empty. Okay, so now I can go A2 to A3. We've made our move. I can go A3 to A4. Awesome. So we can technically make moves now. So I could go B1 to C3. Okay. So technically you could play a game of chess with this. The issue is that all the players would have to enforce the rules themselves, right? Because there's nothing to stop me doing something kind of crazy and just taking your king like that. But in principle, we now have the ability to move pieces around and have them drawn on the screen. So technically, people can play chess if we're happy with them playing by the honor system. I'm not, to be honest. But anyway. let us... Okay, I think maybe this would be a good point to stop for... Not this, but after we've done a check for legal moves. This is kind of an interesting, kind of meaty part of this logic. Like, aside from this kind of stuff, maybe some of the most difficult things. Basically what we want to implement is something like function get legal moves. Right, given a piece position, and we kind of want it to return us tiles we're allowed to move into. So we can stop that out by just returning an empty list, and then nothing will be legal. You know, and then we can have some logic like let legal moves equal get legal moves at the from position. We can say if right, this is kind of what we want to be able to do. Maybe we do this after. Alright, so right now nothing's legal, right? Because we're going to ask, and it's always going to say, hey, there's no legal moves here. So it's implementing this, which is actually kind of the bulk of the logic of chess, I suppose. So A2 to A3. Oh, we've got an error. Contains isn't a thing, possibly. Maybe we have to use index of. I vaguely remember that being a thing. Again, I'm not a JavaScript guy by trade. So we can go A2 to A3. Oh, illegal move. Okay. So we need a way to populate this. And this varies by piece type, right? So we need to basically encode the logic of now of how the pieces move. And I think there are probably infinitely many ways you could do this, but I have one that kind of seems natural to me already. Let's consider... I would say there are two types of pieces. So I'm going to draw a bishop in a kind of abstract, terrible way. There's my bishop. In fact, let's get that board back up. That probably would have helped. You know what? At this point, I can actually just screenshot this, and then we can draw on top of that. Maybe this will help. Sneak peek of my other screen. Spoiler alert, it's OBS. Okay, so let's think about our little bishop friend here. We all know that the legal moves for a bishop are kind of diagonal, right? So right now, there's no legal moves, but in principle, it could go like here, or here. Actually, let's just draw this like here, 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 here. I mean, obviously it can't go here because it's off the board. So the first thing we need to account for is even if this thing can move diagonally, and ignoring for now the fact that it can't just move through a piece like that, it can move diagonally, but only up to, you know, in theory that's a tile it could go to if the board was bigger. So we have that issue, like what are the legal tiles? And then we have, are those tiles like having it stop at the end of the board? And then we have this issue of things being blocked. So the knight's actually easier in a way, because it always just moves from here to, you know, like here, or here, or here. And it doesn't really, it jumps, right? So it doesn't really care, you know, we think of the knight's move like that, or like that, however you want to think of it. It doesn't really care what's in between. Whereas the bishop, you know, it can only go here if it's not like blocked along the way by something. So there are two different things there. Two different cases, I guess, like jumping pieces and like kind of slidey pieces. So the first thing is just to encode in some way the logic of the basic shape of their moves. So the knight having these like potentially up to 8 tiles around it, in this sort of L-shaped pattern that it can kind of move to. And the bishop, the way I think I would do this is, so we could do something with some loops, like loop from its position and keep going like up and right diagonally until we hit the end of the board. We could identify these tiles, then we could do like up and left until we hit the end of the board. But I think there's actually a kind of more brute forcey but simpler way to do that, which is to think of, I guess, like relative positions where these things can move, right? So this is like, so this tile is someone when it can potentially move in, it's on its diagonal, and this is like 1 this way and then like 1 this way. So we could think of this position as being, relatively speaking, being like +1, +1, right? Sort of relative to this. If the bishop was here, then +1, +1 would be this one here. So we could think about it in that way. Like in general, the bishop can move to +1, +1, +2, +2, +3, +3, +4, +4, +5, +5. It can also move to like -1, +1, which is like -1, +1, which is here. -2, +2. So we can just build up a big list of positions they can move to and just have that like hard-coded. And then all we need to do is check, given these relative offsets, figure out the actual tiles those land on, and then say, hey, first of all, is it that even on the board? Like, have we gone off the board? And stuff like that. So I think I'll start with the knight because it doesn't have to deal with getting blocked by other pieces. Yeah, so what I want to do basically is have another kind of array of, I guess, piece moves. I kind of want to pre-populate that in here, kind of like so. So piece moves, the piece moves for a knight are as follows. We're going to create a list of them. Ooh. So we can it can go to, let's do this in a kind of array. So we can go to like +1, +2, if that makes sense, which we're going to encode like this. We can also go to +2, +1. We can also go to -1, 2. You can also go to -2, 1. You can also do things kind of reflected in the other axis, so I can kind of copy paste these. It's basically with all of these as minuses, right? So these are like the relative positions of all of the jumps which a knight is able to make, right? So that means we can say something like this in our get legal moves. So let's have this piece pass through. Since we already have it here. So, what do we call this? What's this doing? It's saying if you've given us a knight, then we're going to look up the relative moves which are allowed kind of for a knight, right? And in fact, we're just going to kind of loop over these, right? So for let set of, so we're going to go over each of these offsets. Then we're going to figure out we're going to kind of apply these offsets to the current position to figure out the actual target, like file and rank. So the file is going to be file of its position plus right? So if you remember, these offsets are of the form, I just kind of quite lazily encoded two little numbers in an array. So the first one is the X, or kind of file offset, so it's one file to the right and two ranks up, which if this knight is here, that's one file to the right and two ranks up, so that's one of its potential tiles it can move to. So I kind of just want to go through each of these, and then we can start to kind of exclude them based on certain conditions. So, right, so this, if you like, is, so if this is at 0, 1, 2, let's take this one actually, 0, 1, so this is at 1 in the x coordinate and 0 in the y, so this is at 1, 0. We're going to add like 1, 2, so this is going to give us 2, 2. But on the other hand, there is a tile like 2 down and 1 to the left down here, which would be 0, minus 2, and clearly that's like off the board, so that's not allowed. So we first filter out positions which are off the board. So I'm going to say if file is less than 0, or file is greater than 7, or file or rank is less than 0, or rank is greater than 7. We know that it's off the board, so we can continue, meaning we kind of skip. Otherwise, let's add this to our list of legal moves, right? So legal moves dot push I think there's a shorthand for what I'm doing here in this object as well. I think I can just do like file rank, but I kind of like to be a bit verbose and explicit. Then let's return. Right, so what's this doing? It's going to start with an empty list, and then it's going to go through every offset which this thing's apparently allowed to move to. It's going to figure out to the pieces position. Determine the actual target tile, right? So I have these legal moves. I'm also going to just pop this up in an alert window because I think that will be helpful to debug this stuff. Okay, so right now this should only work for knights. It will probably crash and get an error if we try for anything else. But let's see what happens here. Honestly, stepping through the debugger would be nice, but okay, so we're going from A2 to, where is it? B to B3. Okay, we got an error there. Because why? Undefined. What's the type? So we should have set something there for the knight. Actually, we have our console down here, so let's start logging some stuff out. Okay. I'll use some like fancier string formatting here as well, but this will work for me. Let's just run this quickly to see what's happening. So B1 to C3. Oh, that's not very nice. Legal move, okay. Okay. Let's actually put this log somewhere else where we have the friendly positions. Where are we? Okay, maybe not. Slightly inconvenient to print out this object here. Let's print out the legal moves. Okay. So we have B1 to C3. Still getting that alert. Legal move. Okay, so we can see what appear to be what it thinks are legal. So that's okay. If that's okay. Get rid of this alert. Let's print out here the requested is to go to 2. Okay, should get some more information down here now. So we're going from B1 to C3. So the issue is that okay, we can actually see a matching entry here, but it's not like strictly matched. Maybe it's to do with the order of these properties. I'm not exactly sure how contains works in JavaScript. So maybe it's that. Let me make sure we put those the same way around. Where are we? Cross position. Let's actually put these the same way around. Maybe that will allow it to match. If not, we may need to like just loop through this list of legal moves and check the coordinates against the one we're trying to make. I'm not entirely sure the semantics of comparing objects in JavaScript. So B1 to C3. Okay, so it appears to have given us a reasonable set of legal moves. I think this is right, yeah? So 0, 2 is like 0 and 0, 2, so we can go here, we can go to 2, 2, we can go to 3, 1, there. Okay, cool. So let us, this clearly doesn't do what we want to, so it's gonna have to be a bit of a search here. If move.file equals 2.file and rank 2.rank equals true. So we're basically searching through the list of legal moves it's given us back to check if the one we tried to do is actually in there. So hopefully this will fix that issue and we should be able to make something happen. So B1 to C3, boom, there we go. C3 to B1, awesome. B1 to F8 illegal move. Awesome. So that basic thing appears to be working. So there are some other rules here, right? Like technically we can move here, I believe, but this shouldn't be illegal because we can't take one of our own pieces. Right, so let's actually look up piece in target position equals board right. So we're going to look up tile. Is it a tile or a square? Tile we're moving to. So let's say if piece in target position is not null and piece in target position dot color is equal to our color. Then we will also continue. Kind of maybe confusing terminology. Continue meaning continue this loop, but skip processing it for this one, which means we won't do this. Okay. So that should now prevent us from taking our own piece. We can test that quickly. So I can go from B1 to C3. Nope, that was correct. Did I have caps lock on? B1 to C3. Okay, that's strange. Okay. No, that's wrong. That's what we want to do. Okay. So B1 to C3. Cool. C3 back to B1. Now let's try and take our pawn here. So B1 to D2 should be illegal. Cool. That appears to do what we need. Let's do another little test. Try and take our queen. So C3 to D1. Again, illegal. But let's try and take an opponent's piece and see how that goes. So C3 to D5. Okay. D5 to E7 should be allowed. Cool. So we can do that. I could probably still take the enemy's king, which we shouldn't kind of technically be allowed to do. But that basic logic appears to be there. Cool. So that works just fine for the knight. I mean, that's basically the whole thing, the whole deal. There's a kind of quirk, which is you can't make a move that would put you in check, but that's something we'll cover later on when we do detecting check. We should probably say can't put yourself in check. Okay, so the one other thing we need to do is pieces which have a more complex move pattern. And what I was thinking is, so for the knight, all we do is we store this list of moves, which is fine because it's always just like one single thing. But I was thinking a way to do this for the bishop, rather than just saying, hey, this is one possible move, you know, this is another possible move, this is another possible move, and checking all of those, we could think about it in terms of like chains of moves, whereby, you know, a chain would be like here, 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 here. And what we could do is we say, we work through that chain, and as soon as we find a move which isn't legal, then we kind of stop, right? So rather than just a list, this is kind of a list of totally independent separate moves. We could do something like this. So we can have a list of not individual moves, but like chains, right? So this is like, you could have a chain of moves which are like up and right. We could have another chain which is like down and right, right? So we'd have 4 of these for each of the directions. And then within these, we could have a list of moves. So it's like another level of nesting, and it would allow us to do something like this. So this is 1, 1. You can also go like 2, 2. So go like 3, 3, and so on. I guess all the way up to like plus 7, 7, and that would be the furthest you can ever move. So I can go 5, 5. Again, this is kind of a bit hard-coded, and we could just write some code to kind of generate these chains as well, like using some loops, but it's hard-coded because the rules of chess are like fixed and established. They never need to change, and in a way this is the clearest and like simplest way to do this, right? So we could have, that's upright moves, not upright but up and right. Then we'd have down right moves. So with down we're going like negative in this axis. And then we can just do something to cover up and left, and down and left. And that's everything, right? Like this is it's kind of a lot, but you know, it sits there on the screen. It's not the end of the world that we have this kind of slightly hacky hard-coded arrangement. But this is every move that the bishop can make arranged into chains, so that we could say, hey, if 1, 1 isn't allowed, like here, 1, 1 would be this, that's not allowed because it's blocked, then we'd just stop evaluating this chain, and then these would, by implication, not be legal moves either. So this is kind of a general purpose way, I thought, of handling jumping versus like sliding pieces in the way that the logic wouldn't change. What it would mean is actually these would need to become their individual like mini lists, if that makes sense. But each chain is just like a single jump. Because obviously if like 1, 2 is invalid, 2, 1 could still be valid. They're like totally kind of unrelated. So this is how I'm encoding this stuff here, and I think it'll make the code which evaluates this very simple. Even though it's slightly verbose, I think this actually works like not too bad. So now I need to turn all these to negative. Again, this is a bit of copy-paste and a bit of manual writing, which I realise I'm repeatedly making excuses for, but you know, if this takes me half an hour once in writing like a chess game or a chess engine, is it really the end of the world that I've done this? Okay, so the one change we need to make here is when we get the legal moves is these are now nested in 2 ways. We don't just have a list of offsets, we have a list of chains, and then each chain has offsets within it. So for let chain of, so it's chains which are contained within here, and then we can say for let offset of chain, something like this. So it's going to be a little indentation. So what I kind of want to do is right, keep track of if the chain is broken, because this continue won't cut it right now, right? It will go to the next thing in the chain, when actually we kind of don't want that to happen. I think we instead want to, oh, actually, I think I can just break. Okay, yeah, this will do actually. As soon as something's not illegal, we break, which means we will stop evaluating the subsequent moves in this chain. So if we try and evaluate this upright chain, we'll consider the first move. If it fails, we will break, and then we just automatically won't consider any of the subsequent moves. So that handles like blocking logic for us pretty much for free and automatically. See how little this code has changed, and it's actually, I believe this kind of this captures the nuance of like how these moves kind of work. So let me try, make sure this works still. So B1 C3, cool. C3 B1, awesome. C1 D2, illegal move. And if you see here, the list of legal moves is actually empty. Okay, I'm going to remove one of these pawns quickly. Or maybe even all the light squared pawns, just so we can test the bishop a bit more thoroughly. Pawns are actually going to be a special case because of that thing where in the first move of the game they can move two tiles at once. So let's go C1 to D2. Awesome. D2 to C1. Awesome. See, the list of legal moves is pretty long for this because, you know, it's a bishop. They can move to lots of places. Let's try getting it in and amongst here and, you know, messing around with some stuff. So C1 to A3. Okay. A3 to A, B, C, D, E, 7. Let's take there. Oh, you know what? Let's actually move the knight somewhere that's going to block this. So let's jump it over to here, right? So B1 to C3, C3 to D4. Oh. Oh, C3 to D4. No, what am I doing? I'm trying to go here. So C3. Okay, E4 over to C5. Okay, now let's try and move our bishop like through the knight. So you see the E7, E7 to C5. We can't take it, right? We also can't go E7 to B4 because it's blocked by the knight, but we can go E7 to D6. Cool. This appears to be doing what we need. So I think the next thing is to handle... let's go for Rook. Okay, it's a very relatively easy one. That's kind of like the bishop, right? Rook, cause. And it's just going to be like kind of like up, down, left, right kind of deal. So up is going to be 1, 2, 3, 4, 5, 6, and then 7. So that's, I believe, should cover the up direction. What's it complaining about here? Oh, I'm missing a comma. That's up. Let's do down. It's down. And we're going to go left and right. It's kind of similar. This is actually right. That's right, and then left. Okay. Now, I mean, this will work, right? Let's run it. So I can go A1 to A5. Cool. I can go A5 to... I shouldn't be able to go straight to A8. Let's test that. Oh. Ah. Interesting. Okay. So that's a case we hadn't cancelled. We hadn't. So this was a legal move, so it let me try the next one. But really, we need to add something where if you take on one of these little chains, then we can't. We should also stop, right? It's an interesting edge case I hadn't considered. So go A1 to A8. Nope. But I can go A1 to A7, and then A7 to A8, then A8 to A1 again, A1 to B1. Cool. A1 to A5, A5 to D5, and so on. Cool. If I do what was it? D5 to J5, that's not a real thing. Okay, yeah, captures that as well. Cool. So that's the Rook. So the Queen is very similar to this, right? So I could just copy paste all of these. I kind of want to just at least use some code to like merge these together. So I'm sure there's a syntax for this, but I'm just going to say bishop. Right, what I'm doing is I'm just adding all the bishop and Rook moves to the Queen, because that's basically what a Queen is, right? Okay, so hopefully I can now say D1 to E2. Nope. Why not? Should have a lot of big moves. Okay. D1 to D2. Yes. D2 to E3. E3 to D2. D2 to D1. D1 to E2. Okay. Did I just mistype there? Yeah, it seems to be moving correctly. Let's go and smash the king. E2 to E7. Cool. Okay, queen appears to be moving okay. King is rather simple. So it can go, one square in any direction, so that's one. Let's copy this. Because it's 8 different directions, right? Probably do this more methodically. So let's go -1, 1. 1, 1, 1, thinking kind of in, you know, this, then this, then this sort of thing. Minus 1, 0, 0, minus 1, minus 1, 0, minus 1, and 1, minus 1. Cool. That should be all the king's moves. So E1 to E2, 2 to F3. Cool. So I think we have the basic moves covered. Yeah. So we've been at this for what, 2 hours? We have the basics going on. One last thing I think I may do is keep track of whose turn it is. That's something we haven't done yet. Obviously that starts off white when we reset the board. That's weird, that doesn't really work. Okay. So let's set. Ooh. And it goes white, so we should probably check that. If p.color is not equal to turn, then something else like that. But what we should do when a move is made is say using strings for these is not super great, but very much does the job for us right now. Okay, so this I believe should mean, actually I still haven't done pawns, so I will come back to that shortly. So this should mean now that I can say A8 to A7, not this piece's turn, cool, but I can say A1 to A8. Oh, it's not white and black, it's light and dark, isn't it? So let me make sure here that we also say light. Don't really even need to initialize this here, because it gets redone by reset board. So now we can say A8 to A7, nope, we can say A1 to A8, yep. We can't now say A8 to A5 again, we can do B8 to A6, cool. A6 to C7, oh, okay, yeah, that makes sense. Okay, so that appears to work for us. Last thing is pawns. I think I may just do a special case for pawns, because they're kind of weird, right? That's also where en passant is going to happen. Actually, you know what, I won't. I think I'll at least have their basic single... No, yeah, their moves are really screwy, right? So let's have some separate logic for pawns, because they are weird. Okay. If type equals pawn, so what I think I need is pawns are going to need some extra data. I mean, I could tell if they're moved just by what rank or file they're on, but I think I'm just going to do actually just shove the data inside them, because for the king it's going to be, we're going to need to do that anyway for castling, because you could move and then move back, but you've still lost your castling privileges, so it's probably something we need to handle. So let's say if piece. Oh yeah, also the interesting thing about pawns is that the dark and light squares, the offsets are different, right? So if we just listed offsets they can move, and actually for light squares it's like positive in this direction, whereas the other ones it's like negative. So I think we can handle this differently. So cause piece.color cause actually, okay, so I think we can, I was thinking I would end up repeating this sort of logic. So actually what I think I'll do is just change how this works. So something like this, right? So I'm just going to add stuff into chains, if that makes sense. Okay. So what I'm saying here is the rank 1 forwards for me. If I'm light, then that's my rank +1, meaning moving up the board from white's perspective. Otherwise, if I'm black, it's moving down the board. This thing here is called a ternary operator. I've been actually avoiding using that, so I'm not sure why I did that here, but yeah, it's a shorthand for like if piece.color equals light, then it's this, otherwise it's this. It's kind of like an if else on one line thing. If 1 forwards equals, actually this will be handled as well by this logic. What I was thinking is if there's something immediately in front, it can't move too. But actually if I just create a chain with like a single move and then like a double move, then that should work, right? So chain.push. File like 0. Okay, let's actually do it this way. So if piece.color equals light, then I'm going to push in, we can move like 1 up. Like that. And then if dot has moved, then it can potentially move up another one. Okay. Else means it's a dark colored pawn. It's going to be -1 and -2. Cool. We also have diagonal taking, so I may, again, en passant will come in later. So So this is moving forwards, and this is taking. God, no. So we need to say let board file +1. Okay, again, I've figured out a slightly better way to do, so let equals. So a way to kind of standardize this. So if it's light, then the forward direction is 1, otherwise it's -1. Okay, so now I can just say something like this, like that. If it hasn't moved, then we're also going to add one tile forwards, and this is like moving 2 tiles forwards. Okay, that looks much cleaner to me. And that's position of file +1, and then position.rank plus direction. So if this is, again, we don't need to do this. So if it's light, then forward direction is going to be positive. So let's consider a pawn that's like here. Then file +1 we here, and then forward direction is here, so this would be top right. Whereas if it's a pawn up here, then file +1 is going to be here, but the forward direction is -1, so it will point to this one. So it's pointing that way or that way respectively, which I believe does what we need. I'm going to say if to right capturing null and piece to right dot color is not equal to piece dot color, then we can potentially go that way. And piece to left is very much the same thing. Negative, piece to left. So technically what we're doing here is it's weird because this is a move which is only allowed if there is a piece somewhere, which is kind of odd if you think about it. So then chains dot push. That's forward move chain. Okay, and then chains dot push move chain. So there are 3 chains, right? So there is for a pawn here, there's a chain which is this tile and then this tile. That's one chain. If it had moved already, you know, if there was a pawn here, then it would just have a chain like that. And then in terms of taking, if there was some other piece here, then this would be a chain. If there's one here, this would be a chain. So there's up to 3 different movement chains for a pawn in terms of how our like move checking logic works anyway. So what we're doing is we're saying that if it's a pawn, then we're going to start building a forward move chain. Actually, let me do this here. It kind of makes sense. First we determine, let's actually put some comments. So pawns move right? So we kind of just, forward direction is going to be 1, it's moving like up, or -1 if it's moving down because it's black. Then we're going to, this chain we're moving forwards, it can always move 1 space forwards. I mean, this will be checked later on to see if there's a piece there that it can take or not, or whatever. And if it hasn't moved, then we also include like 2 steps forward there for that opening move daily. And diagonally, we see if there's something forward and to the right, then if it's not null and it's a different color to me, then that's a move I can potentially make. And it should be a separate chain like that. Right, so 1 move chain. And we do exactly the same thing for the left. And again, I could probably have done this slightly differently. So I could even do the order is right. Offset. Yes, we could call file offset. Like that. Right, that kind of standardizes that slightly. Hopefully the logic follows. Obviously, at any point, if anyone has any questions or stuff doesn't make sense, then please drop a message in the chat and I will endeavor to respond to it. Let's see if this works. So A2 to A3. Ooh. Doesn't like that. So A2 to A3. Interesting. We did something weird here. Probably it looks like in here. 170. What's wrong with that? I mean, oh, so I guess it's possible that it's trying to check this move and there's nothing there. So we should probably do something like if right, so find these coordinates, and we should probably do a bounds check here. So if file greater than 0 or capture greater than 7. Right, so quick little bounds check. Okay, that fixed it. So A2 to A3. Nice. Can I go A3 to A4? Oh, interesting. Okay. H7 to H6. Okay, yeah, it's good. That works as well. Can I do something weird like move my pawn backwards? A3 to A2. Nope. How about A3 to A5? Ah. I'm not remembering that something's moved. That's what's happening here. So, we make the move. Dot has moved equals true. Remember that something's moved. Going to be important for later. So, A2 to A4. Awesome. B7 to B6. Cool. B2 to B3. Let's try A4 to A5. Oh, okay, yeah. So B6 to B5. Okay. Now I should be able to go A4 to B5 and take. Awesome. So what would be nice actually would be able to see, like somehow show all of a piece's legal moves as like a debugging thing. So I'm going to very, very, very quickly make that happen. Just as a way to like round off this test, right? So something like this. So I think when we make a move, so maybe rather than moving, I can just say moves equals go moves, and then return. And then when I draw the board, what did I call it? Debug moves. I'm just going to draw these in this form. So let's do a fill of like semi-transparent green color. File, rank. Okay. So now I believe, rather than actually making moves, it's going to show me the legal moves. So A2. Doesn't matter what I put. Right. Okay. So we have that. So I can say, okay, it's not actually going to make a move anymore. Be handy. I want a way to just list the legal moves or something, right? So, let's do else if dot value dot length equals 3 and value 2 equals. So I'm hoping to be able to do like A2 question mark and for it to just show me all the legal moves for that piece as a little debug dealy. So what I will do is something like this. Board file rank if piece there's a piece there. Then moves equals get legal moves of that piece at that position. Okay, then I can remove it from down, way down here. But it actually will make its moves. Let's say clear that out here and reset the value here. Okay, does this work? A little debugging feature. So I should be able to go A2 question mark. Awesome. B1 question mark. Lights moves. B1 A3. Cool. If I do B2 question mark, it's still going to show me moves for a piece for which it isn't its turn, but in any case, seems okay. So I can go A7 question mark, A7, A5, A3 question mark, or A3 question mark. Yeah, that seems to be all good. Let's check some of the other pieces quickly, and I think we can call it a day. This is pretty successful in my mind for just one stream and 2.5 hours. Whose turn is it? A3. Oh, we should show whose turn it is. Back. E7 question mark. Yes. A5 question mark and move one forwards. That is correct. A5, A4. B2 question mark. Yes, we can go B2, B3. Let's go A4 question mark. Oh, okay. Has it not realized that capture is legal? So there's maybe a bit of a bug there. A4, B3. Yeah, it doesn't like that. So let's see what's going on with that logic there. Okay, rank. Ah, this is wrong. Had those the wrong way around. Could that be it? Let's double check that the code makes sense anyway. Checking bounds okay. Default capture rank. If it's not null and it's not equal to our color, then we can have that offset there. Okay, I think that should be okay. So do E2 to E4, a bit more of a standard opening. Let's then do D7 to D5. Cool. Then let's do E4 question mark. Okay, there we go. That looks good to me. So E4 to D. You can tell my chess coordinate knowledge is not all that great. There's one other issue which I think I may have figured out. So C7 to C5, and then C2 to C4, then C5 question mark. Yeah, it's allowed to take straightforward, which should not be the case. So So I actually need to do something like if Right, we should only do this if there's nothing. We can only move forwards if there's nothing in front of us. Pawns are weird, aren't they? And then we can say, if it hasn't moved, then we can consider moving 2 forwards. So we need to do a similar check. We also need to check bounds. This is not great, so let's push in bounds into another function. Greater than or equal to 0. Right, that's what determines if something is in bounds or not. And then we can replace all the places we do that logic with a call to that function. Nothing happens here. Is in bounds file rank. Okay, if it is in bounds, okay. We need to do something here. If so you know what? Another way to handle this is so if it's in bounds, I'm going to look it up. Otherwise, null. So the reason I'm doing this is that there are lots of cases now where we want to see if there's a piece in a certain position, and that position, you know, like relative to the piece we're trying to move, but the, you know, like here, right? We might, if there was something here, then we could capture it. We also want to check this. In theory, if there's something here, obviously that can't happen. But to avoid like accessing data outside of this grid, we always have to keep checking, oh, is this a legal tile? And then is there something there? Whereas this kind of wraps that all up together for us. So we can do something, we can replace some instances of that. So for example, in here, I mean, technically that's redundant since we've already done that check just there, but you know, we're going to do right. So I can just say get piece at file rank, which will do the bounds check for us. And if it's out of bounds, it's just going to return null, and then you'll get filtered out here. So it just removes a line of code, and it means that for all of these 2 things here, I no longer need to do this, because the bounds check will also be done later on here when we go through these chains, right? Like stuff will get filtered out there, so I don't need to filter. I'll be filtering it here just to avoid an error from accessing an invalid array index, but I'm fine with putting something into this chain which is invalid and gets ruled out later on for being out of bounds. I just don't want to have to keep doing this check to avoid array index errors. So I can instead just say if get piece at file rank equals null. If there's nothing directly in front, then we might be able to move directly in front. And then if we haven't moved and there's no piece in front of us, then that's the case. So we may queue up moves. If we have a pawn up here, we may queue up moves which are off the board for it, but it won't actually happen. Oh. Where are we? We are at 4. Interesting, there's nothing at 3 or 4. Something weird happening here. Probably a missed bracket. One thing that annoys me is on these streams I set my font size really high so folks can read it, but it actually makes it quite hard to navigate around some of the code. There's nothing in front of us, then push that. If we haven't moved, then aha, here we go. If we haven't moved and there's nothing 2 tiles in front of us, then we can potentially move too. Okay. Will this finally do it for us? Oop. Still some bracket issue. Can we do like auto format, I wonder? Is it just me or is this the wrong way around and to the right should be none? I don't know. Okay, I'm going to drop the text jars just so I can navigate this a bit more sensibly. And this needs a little bit of refactoring, I think, into separate files. I'm pretty sure this is all okay. This stuff. Drawing the board works just fine. Drawing the pieces. Probably an auto indent function would figure out if there are any issues with brackets here for us, but I don't think we have that option. Also, I'm used to my editor like highlighting the corresponding bracket and stuff, which is also not happening for us here. Something weird as well with this. I think stuff's getting hidden below the console. Okay, that's what it was. God damn it. Okay, this back. So now, okay, move there. A2, A4, B7 question mark, B7, B5, A4 question mark, A4, B5. Take, there you go. So let's also now do C7, C5, C2, C4, C7, oh, C5 question mark. No legal moves. Which is correct, okay. But now I can do like A7, A6, and do B2, B4. And now I should be able to go C5 question mark. Awesome. C5, D4. Ooh. No, C5, B4. There we go. Awesome. I think we have first couple of steps down. This was a big one, right? Checking for legal moves was a whole bunch of work and most of the the core logic of chess, I suppose. Next we'll move on to special moves and then detecting check, making sure that putting yourself in check in any way isn't considered a legal move. Detecting the end of game conditions, stalemate, and some of the weird draw stuff. I realise there's another special move we kind of need to cover, which is pawn promotion. We'll need a whole other kind of syntax for that. So if we're lucky, we'll be able to do this next stream within a couple of hours. We'll actually save this into the folder for this thing. Don't know why you need to wait to see me do this, but cool, definitely these notes. Yeah, I think this is the huge bulk of the work, I think, and I think even though some of this stuff is fiddly, we may be able to do it next stream within 2 or 3 hours. Probably also spend a bit of time tidy up and refactoring what we do have. Yeah, I would say thanks for tuning in. Anyone who's interested in what we do, you can follow us on Twitter. I'll ping the link in here. We also have a Discord where you can follow our more major game development efforts. I mean, this is kind of a little side thing we do for fun, but we are working on a game called Steamhounds, which is a turn-based tactical thing with some sort of similarities to chess, I suppose. It works on a grid, and there are similar movement, positional, pinning, and stuff like that. But if you're interested in jumping on board with that, then you can join our Discord. I realised I think I had something which gives links. Okay. I did Nightbot recently, which should do this for me. Anyway, I'm rambling. I will say goodbye to everyone. I think it's just kind of a successful stream. We've got the basic core logic working, aside from castling and en passant and stuff. And I will see you next time where we will finish up the core chess gameplay here. Awesome. Thanks, everyone.